All right, welcome to our fifth video of our fifth unit of AP Chem. This is called pressure volume work. It's not a very common concept you'll see, but you do need to learn it at some point. So here we go. So the work involved in the expansion or compression of gases is called pressure volume work. This is the kind of work involved in a gas moving a piston, and put simply, it involves the change of volume, which changes pressure, or vice versa, and thus generating work, which we know is quite involved with energy. This is, again, really how pistons work, to an extent how cars and many other random mechanical objects that I have not much idea about, sorry. But this is pressure volume work. So, long story short, kind of. As the gas expands, the pressure builds up, which causes the piston to move and release the pressure. Now let me show you kind of a picture of what that kind of looks like. So you've got a piston, basically a chamber, and you've got this kind of stopper thing. Okay, and we're going to pretend that's actually sealed, and you've got gas in here. And basically, as the gas expands, typically involved from like heat or something, this starts taking up a lot more space and kind of pushing up and out to take up room. That builds enough pressure that the piston has to move to release the pressure. And now you've got gases that are going off. That work, however, basically that movement then releases that energy, kind of potential energy. Now it releases it. Now you can use stuff with that energy. As it gives it space, the piston will then cool down and kind of repeat this cycle. So the work done, therefore, is due to changes in both the pressure built up and the volume. Now it's expanded. And in this case, the work, which stands for W, it's one of the very few variables in chemistry whose letter actually, makes sense, can be expressed as work equals negative P times delta V. So it's called negative pressure times delta V. Keep in mind you're decreasing one, hence the negative. That's kind of where this work comes from. So just to remind you, the P is the pressure that the system's being held constant at. The goal with the piston is to expand and release that volume to keep it at that pressure. Delta V is our change in volume. All right. In addition, pressure volume work is typically measured in liters times ATM, which should make sense since those are units of pressure and volume. However, we don't really think in liters ATM. So 1 liter ATM, I know that looks like a liter minus ATM. There's actually a hyphen there, just the way my equation editor works. It makes it look like a subtraction. Equals 101.3 joules. So to move, basically what we're saying is a change of one volume at a constant of 1 ATM will take 101.3 joules. So there you go. All right, let's do a practice example. If a balloon is expanded from 0.055 liters to 1.403 liters against an external pressure of 1.02 ATMs, how many liters ATM of work is done? Now, I know we talked about pistons, but this is also the type of work you've got when you're blowing up a balloon. Okay, it's starting pretty small. You're trying to inflate it. And the outside pressure is basically 1 ATM. A little bit more, just, I don't know, let's say you're below sea level. So how many liters of ATM of work is done? And then we're also going to figure out how many joules of work is done. So, and actually if you wanted to, you could find calories to figure out, how many candy bars, if you will, you're burning off by blowing a balloon. We're not going to do that, but you could. So our work is negative P times delta V. Well, our pressure is 1.02 ATM. And our delta V is going to be 1.403 minus 0.055 ATM. So when you subtract that, you get 1.348. So that basically says we're inflating something about 1.348 liters against an external pressure of 1.02. Put that in your calculator, and you get negative 1.3 0.75 liter ATM. That says that we are going to expend that that much work. All right, now I'll let you write that down because I'm going to erase these things and then we're going to convert this to joules. So I'll give you just a second. Okay, hopefully that was enough. Our next step is to convert that to joules. So we have that 101.3 joules is equal to 1 liter ATM. Put that in your calculator and you get 139.29 joules. That is our final answer. One trick that I just kind of realized is the 101.3 joules, while I may be thinking, oh, that's kind of a random number, that's actually how many kilopascals, I think it's kilopascals, it might be Pascal, one of those, are in ATMs. So it's a number we've seen before, and I don't honestly know if they're related, they probably are, but that 101.3 we've seen before. Just trying to help you remember that. But there you go. That's pressure volume work. It's just the work done due to pressure and volume changes. Like I said, you won't see that a whole lot, but when you do, I want to make sure you're prepared. As always, thank you for watching.